Greetings everyone. I am Uday Sharma from the Triply Department of Institute of Aeronautical Engineering. Today, I am going to discuss about the topic all aluminum conductors. Let us see what is a conductor. A conductor acts as a medium to help the flow of electrical energy from one place to another place. Conductor in the transmission systems plays a key role in the transmission of electricity. Like based on the type of the conductor, the cost of the transmission line varies. The voltage and the current carrying capacity varies. The strength of the line and mainly efficiency varies. Like if the conductor is thick, or if the conductor is made of aluminium or copper, or how long the conductor is, etc., can be varied. The characteristics of an ideal conductor in the transmission are maximum conductivity without losses, which should be less cost to make, or which should be less cost to lay the transmission lines all over, and it should have high tensile strength, so it could not snap in between the transmission lines or when there's a heavy tension. Introduction to aluminum conductors. In the early days, copper is used in the transmission lines, but aluminum has slowly overtook the role of copper in transmission as it was as it was way cheaper than copper and offers large diameter while carrying the same current, thus helping in reduction of corona effect in the transmission. We know that copper is replaced by aluminum as it provides larger diameter than the copper. It also reduces the corona effect, which can be simply defined as ionizing of surrounding air particles due to the electron flow of electrons in the conductor wire. This leads to losses and a heavy strength or tension on the conductor wire, which also gives in the reduction of efficiency. So, bringing the aluminum wires into this scene makes reducing the losses, less of corona effect, and slight increase in the efficiency. There are different types in these aluminum type conductors. There are all aluminum conductors, all aluminum alloy conductors, aluminum conductors steel reinforced, and aluminum conductors with alloy reinforced. Aluminum and these different parts are all of overhead conductors and transmission conductors are also called as power distribution conductors. These conductors are simply, as discussed earlier, are all aluminum conductors, all aluminum alloy conductors, all aluminum alloy conductors with steel reinforced and also alloy reinforced. The overhead aluminum conductors are used as power transmission and distribution lines. All aluminum conductors are made up of one or more strands in the aluminum wire, depending on the specific applications. As we can see, all aluminum conductors or all aluminum alloy conductors are made up of multiple strands based on the requirement of aluminum only, whereas aluminum conductors with alloy reinforced is having a center or middle strands made up of alloy for higher strength, and similar condition as aluminum conductors with steel reinforced. These two are steel reinforced. The steel center part is made up of steel strands in between the aluminum conductors. For the higher strength, steel gives the higher strength. Let us see what is an all aluminum conductor. All aluminum conductors are refined aluminum standard conductor with a minimum metal purity of 99.7%. It is principally used in urban areas where spacing is short and our supports are close. 99.7% pure aluminum is used in making of these aluminum conductor lines or aluminum transmission lines. These are used when the spacing in between these transmission lines or poles is less. It can be also used in the coastal regions owing to its high degree of corrosion resistance and is also extensively with the railway and metro industries. As we are using only aluminium, it is less reactive towards the corrosion. And it can be also used in the railways and metro industries. Concrete lay standard aluminum conductor is made up of one of more strands are drawn with 1350 aluminum alloy. The conductors are used in low, medium, high voltage overhead lines. AAC or aluminum conductors has seen extensive use in urban areas where spans are usually short but high conductivity is required. Here, 1350 aluminum conductor is a specific type of conductor which represents different types of metals or alloys used in this conductor making. The wire is suitable for use in span on wood poles, transmission towers, and other structures where high tensile strength is not required. Application range from extra high voltage transmission lines to subservice spans at distribution or utilization voltage on private premises. All aluminum conductor is the most economical bare overhead conductor due to its lighter weight, its offer easy handling during installation and use of simpler fittings. As it is, we are using only aluminum compared to the rein- different reinforced conductor materials or transmission lines. All aluminum conductor is much lighter in the lighter in comparison. So it is less economical. I mean, it is most economical, which has less cost and it is lighter. It offers easy handling as it can be fitted easily to the transmission lines. The ideal features or the main features of an all aluminum conductor is defined as they are highly resistive towards the corrosion. That is, they are less prone to corrosion. They have high current carrying capacity, as we have discussed earlier. They have also can extra high voltage or low voltage conditions. They have high carrying current capacity. They can be used in transmission lines of low medium voltages, as we have discussed earlier, in the urban areas and the domestic power supply, where the spacing between two poles or where it is crowded areas. We can use this all aluminum conductors. They also carry few They also carry few disadvantages, the all aluminum conductors. They are not easy to handle, as we have discussed earlier, as it's all aluminum and they cannot have much tension as the AC are compared to the other conductors. Like there is no reinforcement in the AAC. This they cannot handle much tension. They tend to break in the high tension conditions. Based on the requirement of the cables, it is based on the load of the aluminum cable. The size varies. The size of the cable increases with the increase in the load voltage or the voltage which needs to be transmitted. That is, the number of aluminum strands in the bundle cable increases. The size of the conductor also defines the resistance, the temperature handling capacity, the current capacity of the conductor. Suppose this is a smaller cable which contains low voltage and the higher strands of the 91 cables for high voltage and this for the medium voltage conditions. Based on the conductor size, the voltage carrying capacity also increases or decreases. We can see in this table that the number of aluminum area or the coverage area of the aluminum, number of aluminum wires, individual diameter. As you can see, the 7 aluminum wire strand or the smallest as we have seen in here. This 7 aluminum strand is can see here it handles 74 kg per meter length, 74 kg per meter weight, and it can handle up to 109 ampere degree at 75 degrees at the maximum peak temperature. It can handle of 109 109 amperes of current, and at the maximum temperature it can handle 129 amperes of current. As we know, as strands increase based on the area, suppose this like 19 strands, the conductor of higher aluminum area to the strands. We can see that at nominal temperature, the 468 amperes is uh, can be transmitted through these lines. At the highest temperature, you can use 586 amperes, which is almost 5 times the 7 amperes. As we have discussed earlier, the 7 aluminums based on the size of the conductor, the current carrying capability or the voltage carrying capability varies. And this here, as the number of lines or the number of strands of the aluminum wires increase, the current capability is increased. Thank you. This is Uday Sharma signing off.